Hello.
Yes, ma'am.
Yeah.
Ma'am, it's audible now.
Okay,
Okay,
perfect.
got it.
Start. We'll start now.
Okay, fine.
So fluid mechanics. Yesterday, last class, we have been discussing about fluid mechanics, introduction and other things. We'll start today. Fluid mechanics is basically the branch of science which deals with the study of fluids. Study of fluids in motion as well as in rest. That is a fluid mechanics. And as well as if it is in rest, it is called fluid statics. If it is in motion, it is called fluid kinematics and fluid dynamics. Fluid kinematics and fluid dynamics, again, there's a difference between these two branches of fluid kinematics and fluid dynamics. Fluid kinematics is study of fluids in motion without considering the pressure causing the motion of the fluid flow. And fluid dynamics is defined as the study of fluids in motion considering the pressure causing the motion of fluid flow. So basically, when you are discussing fluids, either it can be fluid in motion or fluid in rest. These two things will be considering that's a major component of a fluid mechanics. You can say in general, the fluid mechanics consists of these two things. Whatever may be the problem, it will be covered in any of these two categories, which combines with fluid mechanics. And applications where you can having an application of this fluid mechanics part with respect to civil engineering or with respect to global scenario. You might have heard about computational fluid dynamics, which is very much important for aerodynamic problems and aerofoils and other things. And other than that, we can have with respect to civil engineering, the fluid part is very much important when we are dealing with structures, hydraulic structures, because if you are taking any water resources, channels, either it is a river or it is a canal and whatever may be the streams and other things, we are dealing with structures for storing the water. So in that case, how to design those structures? So you need to know the loads, or not only the loads which is coming on the structure like sulfate and other things. Other than that, you are considering the fluid load. What is the hydrodynamic effect of these forces on the structures? That is more critical. That is more critical. By generally, when I say fluid, it doesn't mean that it is only water. It comprises of both air, gases and liquids. So generally, when you are talking about fluid, it comprises of both liquids and gases. So maybe for with respect to our scenario, we are constraining with water, but doesn't mean that fluid mean only the water. It's consisting of both. So study of the effect of these things with respect to various structures is what is our day-to-day and engineering problems to be addressed, either in aerodynamics or in civil engineering or in electrical engineering. Wherever the engineering you are taking, definitely it is having the application. So that is why it is considered as the fundamental subject for any type. Hello?
Ma'am, there is lot of background noise, ma'am. Your audio is not clearly audible.
Hello? Is it audible now?
Hello?
Hello, is it audible now?
Ma'am, there is lot of
Ma'am, you
background
are
noise.
audible. It's just that the background noise is creating.
Voice is breaking, huh? Hello?
Ma'am, background noise is coming.
Okay, I closed it. Maybe fan is there, otherwise no noise. Okay, will you hear me now? Okay.
Yes, ma'am.
Yes. So when you are talking about fluid mechanics, the fluid mechanics application of fluid mechanics is enormous in engineering field. Not only in civil engineering, but also it is having applications in all the other fields also. So unless otherwise you understand the subject very well, that would be most useful for you for your own applications where you want to apply. Okay, now maybe we will start with um, basic properties. Whether the screen is visible?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, ma'am. So here, basic properties of fluids. Probably you might be knowing what are the basic properties of fluids. First property what we are going to discuss is density or mass density of a fluid. What is the mass density of the fluid? Usually it is defined as mass of fluid divided by volume of fluid. Am I right? Am I right or not? Anybody?
Yes, ma'am.
Okay. I will ask somebody. Aniket Singh Tamar. What is the mass density of water? Aniket Singh. Aniket Singh is there or not? Not responding. Aniket. Anirudh Kumar. Anirudh Kumar.
Yes, ma'am.
What is the mass density of water?
1, ma'am.
1. What is 1? What is the unit?
1 kg per meter cube.
My God. This is 1 kg per meter.
Ma'am,
1
Anybody?
1,000
1
kg
gram
per
1 gram
per meter cube.
centimeter cube.
Is
1 gram
1,000 kg.
1 gram per
ml. 1 gram per
centimeter.
ml.
1 gram per cc or 1000
1 gram
kg
per
per
ml.
meter
1000 kg per meter cube.
1000 kg per meter cube or 1 gram per cc, isn't it? What is the mass density of water? Either it can be 1000 kg per meter cube or 1 gram per cc. Cc means centimeter, cubic centimeter, right? Okay. So this is a mass density of water. And if I want to express in terms of mass density in SI unit, I can say it is 1000 in terms of kg per meter cube. In terms of SI units, it is kg per meter cube. And so mathematically, I can write density as in terms of what is a symbol normally we express. It is expressed as rho. Rho is a symbol which is used for expressing the density of a fluid. Okay. And then next is specific weight. Density is a simple thing which you might have seen in your lower class itself. And what is a specific weight? Otherwise called weight density. Specific weight is otherwise called weight density.
Weight per unit volume.
Very good. So it is usually expressed as small w, and weight of the fluid divided by volume of the fluid. And weight of the weight per volume, unit volume of the fluid is called, or you can say weight per unit volume of the fluid. It is called your weight density. So mathematically, if you write, I can write weight density as how I can write weight of the fluid is, what is the weight of the fluid formula?
9.8 Newton, ma'am.
Can
Rho
you
Vg.
rho g? Am I right? Sorry, Not rho g. What is the weight
Rho
of the
V into G, ma'am.
m into g, right? Can I write like this? M into g.
Yes, ma'am. Yes, ma'am.
So, in that case, mg divided by volume. But what is your m by volume? M by volume is nothing but rho. Am I right?
1000.
No. Definition I am asking. So, m by volume is density multiplied by g. So, W is also rho g. So, that is a relation between your weight density and mass density. Okay. Then this is rho g, your weight density or unit weight is your specific weight is, and what is the specific weight of water? Of water will be
9 kg per meter cube.
tell me no
1000 Newton per meter.
1000 into
Newton per meter.
9.8, ma'am.
how much it is?
9,810.
Am I right? Hmm? Is it right now? Because rho is 1000, g is 9.81, 1000 is kg per meter cube, and your this thing is 9.81 meter per second square. So 1 kg meter per second squared is nothing but 1 Newton, right? Then you'll be getting, and divided by meter cube is there, so you'll be getting 9810 Newton per meter cube. Is it right? So this is the weight density of water. Weight density or unit weight of water is 9810 Newton per meter cube. And what is meant by specific volume of a fluid? So specific volume is defined as the volume of a fluid occupied by unit mass or volume per unit mass of a fluid. So specific volume is defined as the volume of a fluid divided by, or you can say reciprocal of unit weight. Volume of fluid mass of the fluid. You say it is a, it is the mass of the fluid, or you can say it is a reciprocal of mass density, not weight of the fluid. Can also be expressed as 1 by rho of fluid divided by mass of the fluid, or it could be 1 divided by rho. Am I right? Okay. Will you hear me? Hello?
Yes, ma'am. I can
Yeah.
hear you, ma'am.
Yes.
Okay. Pa. So specific volume is expressed as, what is the unit then? What is the unit of specific volume? Aditya Kiran. Aditya Kiran, can you tell me? What is the unit of specific volume? Nobody is there. Then Amit Vikram.
Ma'am, it's meter cube per Newton.
Not Newton. Why Newton?
1 by rho.
1 by rho, it's reciprocal of density, means its unit should be meter cube per kg.
So unit should be meter cube per kg. Okay. Now we'll go to the second part of it. And normally the specific volume applications is only in gases. What gas flow problems we'll be having these applications. And next we'll pass on to specific gravity. So what is meant by specific gravity?
Density of object upon density of water.
Yes, that's all. Density of any fluid or liquid divided by density of standard fluid. That is a definition, basic definition. So I can express S for liquids and S for gases. Liquids can say either it could be weight density it can be either weight density or density divided by same thing. Talking about if you are talking about liquid, and if you are talking about gases, gas of gas. Yeah. Okay. So specific gravity can be of two types. It can be for liquids or for gases. For liquids, it is weight density or density of a liquid. For other the standard fluid is water. Similarly, if it is a gas, if it is gas, weight density or density of gas, there will be weight density or density of air. And what is the weight density of a liquid here? So from this formula, what you can arrive at is, you can arrive at weight density of a liquid. You can express capital S in terms of, can I express like this? S is equal to, then sorry, weight density, small w is equal to, not capital W, small w is equal to your S into 1000 9.81. So what is this? This is W of liquid. Okay. S into 1000 into 9.81. I can write like this. So what is the unit? Newton per meter cube. Similarly, density of liquid. Input is it clear? Is it okay? But whether I will be able to see my screen or not?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
It's going on and off.
Okay, I will share it again. Yeah. This is what
I'm visible now.
Yeah,
Visible
this is
now,
what,
ma'am.
yeah. This is what we discussed now. So here your density of a fluid is mass of fluid divided by volume of fluid. So density of water is 1000 kg per meter cube or 1 gram per cc. And specific weight or weight density, usually W is expressed as weight of fluid divided by volume of fluid. And hence I can write W is equal to mg divided by volume, or W is equal to rho g. Okay. Now W of water, if you are writing 1000 into 9.81, you will be getting 9810 Newton per meter cube. And the specific volume is defined as reciprocal of density or volume of fluid divided by mass of the fluid, or 1 by rho. The unit is meter cube per kg. And specific gravity is defined as either for liquids or gases, it is weight density or density of a fluid divided by weight density of or density of a standard fluid. So for liquid, standard fluid is taken as water. So hence for S for liquids is equal to weight density or density of fluid divided by weight density or density of water. And for gas is weight density or density of gas divided by weight density or density of air. And hence weight density of a liquid is S into 1000 into 9.81 Newton per meter cube. And mass density of liquid is S into 1000 kg per meter cube. Is it clear?
Yes, ma'am.
Okay. Just I will share one problem. Maybe I can do it in another 5 minutes. Will you be able to give me answer? Calculate specific weight. Maybe if you have notebooks, you have the habit of writing. Otherwise, you will forget habit of writing. Calculate the specific weight. Come on. One liter of 12 newtons. Yes. Will you be able to do in your notebook? Please finish it. We have 2 more minutes. 5 minutes more. Or you can do it in your laptop itself if it is, if you are able to do it in the laptop itself. So volume is given as 1 liter and weight is given as 12 newtons. Okay. Now you have to find out what is my specific weight. So weight is known, volume is known. You can find what is your specific weight or weight density. And W is equal to rho g. Hence, if you know W, then you will be finding out what is your rho. Then specific gravity is rho of liquid divided by rho of water. That's all. So tell me the answers, please, quickly. We will see who is telling the answers correctly first.
$12,000 Newton per meter cube, ma'am.
Which one?
W.
W. Okay. Good. Next. I will write. Who is answering? Tell me name.
Density is 1224.4.
Okay. 1 to 2.4. No, it is very less.
One two two 4.48, ma'am.
Yes. 2, 4. Okay, next. Yes. What is specific gravity?
One 1.2232.
Very good. So you have done it in 2 minutes. 1 minute. Very good. Next. Everyone has finished? Shall we go to the next problem?
Yes, ma'am.
Calculate the density. And weight of 1 liter of petrol. So here also 1 liter. So volume is 1000. So if it is 1 liter, what is the conversion? Maybe those who are not knowing it, I will write. So you can write 1 liter is equal to, what is the conversion? 1000 cc, right? 1000 cc, 1000 cubic centimeter. Or you can write that is equal to 0.001 meter cube. Okay, this is the conversion for liters. 1 liter is equal to 1000 cc or 0.001 meter cube. Now you have been knowing the volume and specific gravity is given as 0.8. Now calculate the density. And then density, specific weight, and weight. It has been asked weight. So you know specific gravity, you can calculate the weight.
Ma'am, density is 800 kilogram per meter.
Okay.
Ma'am, weight is 7.648 kg.
1.648. What is the unit?
Kg. Kg.
Weight or weight density? Which one you are telling?
Ma'am, weight.
Weight. What is the weight density?
Hmm. 7848, ma'am.
7848 Newton per meter cube. This is 7.648 newtons.
Ma'am, sorry, that is 7.848.
Oh, okay. Yes, obviously. So your this thing is on. 1000 only. You are directly dividing by 1000, since you will be getting only 7.848. It is correct. So weight density, if you are dividing divided by 1000, because your volume is 0.001 weight. Okay. 10.3 minus. Okay, fine. So
Hello, ma'am.
yeah,
Ma'am, the next period has started, ma'am. Sir has started the class for next hour.
okay, I will close here. I will close.
Okay, ma'am. Okay, thank you.